Hello everyone. The project name is Bitcoin Prediction. So in this project we are using LSTM model like long short-term memory network. So it is trying to perform multi-output regressions, like specifically whether the key market indicator is open or high or low or close price. Like if you enter any date means, so on that day whether the price is high or low or close price or trading volume or open, like that it will predict there. And then the models are evaluated by using RMSE. So that which means root means squared error and the coefficients of R square for the each target variables. This is our block diagram. So first we need to collect the data set and then we are doing feature engineering. So after that we are splitting the data. Okay. So we will train that model. So our model is LSTM. So and we will evaluate it that R square like that. And we are integrating with the web pages. So this is my train code. First, we need to put the required libraries like pandas, NumPy for the data manipulating and Java to save the model and SQL. So we are importing linear regression and multi-output regressions. So in TensorFlow, we are importing our model LSTM Squintial and this matplotlib for the visualization purpose. So first of all, we need to load our data set. So and then this is pre-processing date time. So this is by using this pandas, we are converting to the date time. So which will be easy to extract date time from the features. So same thing, we are extracting time features like hours, days, days of week, month, this and all our feature. Everything we are extracting here. And then lag features. So this is closest to the 1 day, previous day or before days. And we are adding 5 days and 10 days here. So this is RSI, which is nothing but that stock price will be right. That will be different. So we are calculating by using this RSI. And then we are using this drop now function. We are dropping some of the columns, which the column with the empty values. And then we are selecting our features and target. So this is our features and this is our target. Open, high, low, close, and volume. And then we need to reshape our LSTM. So samples, timestamp, and features. This is three things. So that will be converted to the 3D format like samples and this instead of timestamp will be one and here features. And then we need to split for training and testing. So 20% of data I'm taking for the testing and 80% for the training. So to train that, we need to initialize our model. So our model is LSTM. So by using this squintial function, I'm initializing our model and I'm adding multiple layer here. So LSTM for the 64 units and I'm keeping return sequence equal to false. And then I'm adding dense layer as 2. One is 32 and this is final dense layer. So which is useful for the output layer will be the multiple output regressions. And then this model I'm compiling with loss equal to MSE. So which means mean square error and optimum is equal to error. So I'm keeping here early stopping also like patient equal to 10. So whenever you start to run the train code, so it starts with a box. So up to 10 epochs, it will notice whether our model is getting improved or not. If it is not means by using this early stop, it will terminate. So by using this fit, I'm giving that epochs is equal to 100, batch is equal to 254 and validation for the 10%. So and then we are predicting our models. So after that, I'm using linear regression also. I'm comparing with LSTM and linear regression. Same thing, this prediction for both LSTM and linear regression and evaluating for both the LSTM and linear regression. So here I'm printing that R square and RMSE. So finally, we are calculating that average R square for both LSTM and linear regressions. So at last, we are printing its model's accuracies. And finally, we are saving that model for the testing purposes. And finally, we are visualizing our price predictions. So like linear regression close for LSTM close, actual close, and prediction which is actual close price, timestamp like that. So this is app.py, this is web pages. So by using Flask, like it is a framework of the Python, I'm integrating with the HTML and creating as the web pages. So this is our database Bitcoin. So whenever the user enter their details, right? So the details will store in the database. So same thing, what we save the model in the train code. So that thing we need to load it and we need to do feature engineering for this input. So this is all our routes. So for index, register, login, and logout, about, contact, and finally for the prediction pages. So this is my web pages. So Bitcoin trend analysis. You can see that here we have button like login, register, contact, about, and prediction. So directly you cannot access the prediction page. First it will ask to log in to access these pages. So before that we need to register here. So once if you register, you can log in and then we'll access the prediction page. So if you have any queries, you can contact through this form and about pages. Like what are the procedures we have done in the models and done in our project, we have kept in the about pages. So this is our prediction pages. Like if you enter feature date, like I'm entering as 2025, 12th month and 12th day. So let's predict the price based on the date. So here it is showing that open price and high, low, close. So everything is 46. Okay, let me show some other example in 2047. So so here it will be highest like 654, 655, for low 654 and close 56. So based on this date, it will predict the prices.